Just give me a second. Before getting into the topic, we'll say a small video. Okay. So you can follow the captions which are the scrolling on the video, and we'll get into the topic. Anybody experienced this the shocking sensation once you are coming out of the
Yes.
and sometimes after waking up while going and touching the door, you'll feel a shocking sensation. Okay,
Yeah.
fine. Okay, good.
I think screen is in mute position, sir.
Sorry,
Sound is not there.
Video,
no, the audio
video
is not.
not playing the sound.
Only video, only video. Just follow the captions.
Okay.
Oh,
Yeah. Okay, what we have seen from this, what we understood?
సార్ ఆడియో కూడా ఉంటే బాగుండేది, మూకీ సినిమా చేసినట్టు ఉంది.
It is
Okay,
a collaboration between atoms like neutrons and protons and
so
electrons.
basically there is an imbalance of the charge, which will result in a creation of shocking sensation or while trying to balance, if the amount of generation is very high, while discharging, it can create an invisible sparks. Even if you see general examples in our house itself, there are certain fabrics also high prone to generation of this static electricity. Okay. Just a second, I will share my screen. So when I say fabrics, so basically nylon, polyesters, even acrylic, rayon, etc. They are highly tends to generate this static electricity. When I say lower side, we can take a cotton, wool, and silk and linen. These are less prone to generation of static electricity. Okay, so why we need to discuss on this? What will happens if you're not giving enough attention to the static electricity? What will be the consequences? What will happen? Any guess? What will happen if you are not taking care of static electricity?
It can cause electrical
Char-
injuries or fatalities also in some cases.
Electrical
It's
injury. Kumar, you
it
mean to say that
depends upon
electric
the
shock?
yes, sir. It depends upon the how much ampere enter in your body. It partially fatality.
Static electricity.
Due to static electricity.
Okay. Any other answers?
If the static electricity may be generated near the petroleum product like a plastic bottle with our static, that may be explosion of that mm, bottle. That will be fatal.
Mm-hmm. Okay.
In also, sir, gas spilled also. If somebody, if venting is occur, if there is any PVC pipe, due to static generation, there will fire. There is also fire generate.
Okay. So have
Basically, it
you,
may cause another source of it. It may become a source of ignition, or it may create in some fire scenario like that.
yeah, correct. Okay, good, thanks. So basically, static electricity, as we seen in the video, it is an imbalance of energy. So when what happens, any friction happens or any collision happens, the imbalanced negative ions tends to leave the body, so it is become positively charged. Then other bodies where it's have a negative charge, when it is comes closer, it is becoming neutral. During at the point of time, based on the amount of accumulation of negative or positive charge, there it will have tends to create a spark. If you see during the rainy seasons, we'll get the thunders. even lightning. So Earth is in a discharge. That is also a best example we can say for static discharge. So how it gets generated? So basically it is very weak. I mean to say that how strong it is very weak. And it is very short time, this thing. When it gets generated, as sooner as it gets discharged, it won't take much time. It is so fast. So basically it generates because of friction, collision, and separation of any two dissimilar objects like plastic, paper. Even in our childhood, we would have seen this definition. When you take in a comb and rub on your hair, so the tiny piece of papers can attract to that. Again, that is also a difference. Then, as we see in the door handle, shocking sensation, even balloon, or rubbing a balloon, again, the hair cell is automatically gets attracted. So basically, it happens with the friction, collision, and separation. That's why when I say friction, collision, and separation, in a friction point, where we can take an example of any chemical pipeline, where we have static jumpers or strips, where we use those strips as continuity to the static electricity and will connect it to the earth fit, so it gets discharged safely. Even when I say collision as an example of reactors or any storage vessels, where we use the dip legs. So the dip leg will take the fluid at maximum to the bottom of the storage container or the reactor, so that with that way also we can avoid the static generation. Basically, it is an imbalance of electric charges within the surface or the material or between the materials. The charge remains until it is able to move away by means of any electric current or electrical discharge. When the amount it is increased, then only we could able to see the visible shock. Even as you mentioned, the fabrics, the nylon or any rayon materials, or some kind of t-shirts also. After using a whole day, when you go before a bath, so if you while taking off the t-shirt also, you could see some cracking sound. Even some more kind of fabrics while you are doing ironing, at the time also you could feel some cracking sound. That is also because of static electricity. When we say importance, it is becoming increased after the evolution of chemical industry. So increasing of and also use of insulating materials, and also rubber, chemicals, petrochemicals, films, and also flammable gases, vapors, and dust. So as already somebody mentioned, when you are using handling with any petroleum products nearby, in case of any sudden discharge happens, there is a chance to explosion. And as Kumar mentioned, it is going to be a cause for an explosions, any fire accidents. What will happen? Somebody suddenly comes from, and also there is a loading or unloading happens. There are vapors in place. Suddenly he touches any pipe. Due to that, any discharge happens, resulting that is in an accident. That's why where we use this flame-proof electrical fittings, and also then we use the static jumpers, even wristbands when you are charging any material manually. In that case, also we use the wristbands to avoid the static generation. So it gets connected to the earthing strip, so that it will get discharged on immediate basis. And also we used to have the touch pads. Even we used to have hanging chains in the shop floor area, near the shop floor area. Nowadays, the hanging chains are very minimal. Most of the time we'll have touch pads outside the production area, or where static sensitive areas where they touch the pad and they will enter the shop floor. So basically, the generation of electricity is a surface phenomenon associated with the contact and separation of dissimilar surfaces. And friction is not necessary to generate the electric charge, but however, it encourages the release of electrons. As we've seen in the video, when the friction happens, the loose bound electrons will get released and it will become positively charged. And production of ionizing particles, conditions necessary for generation of static electricity. Basically, it's a means of electrostatic charge generation, means of accumulating, generating charges and maintain potential difference. So as I mentioned, the difference between the charge particles, it will get discharged. And there must discharge of accumulated charge to give a sensation or effect of static electricity. If the discharge, the separation is adequate energy, it will give a spark which can ignite the flammable mixture. When we say flammable mixture, it is in the vapor which is generated near the storage vessels or any utility area. Even in case of spill happens also, there it can form the what you call a cloud, a vapor cloud. Even those vapor clouds also can get triggered by the static discharge. What will happen? Basically, the static is first it's generated, then it will starts accumulating, then lastly discharges. These are the three steps it will happen from the generation to the discharge. It generate, then it will accumulate, then discharge. Out of these three stages, only last one is visible. So we can only visually see the discharge. Especially in the nights, we can see in our clothing also, we could see these sparks. In the street is not possible because of excessive lighting, or sometimes in the nights we can see it. But in the home, you can do this experiment if you have any nylon clothing or any bed sheets. So you can try for this. Then contact charging by two dissimilar materials in contact, plastic films passing over the metal rollers. So it is about where plastic manufacturing, where they make it bundles for delivery. It should be earthed, and powder flowing through the duct, or people walking over the carpets may be highly charged. As we see an example, when you're charging in insulating mats, so you'll get charged highly. Liquid flow through the pipes generate a charge due to the adsorption of the impurity ions, and also this may readily occurs when filters are used with petroleum products. Even when you're using the filters from the pipeline, it will go to the filtration process. Even it is going to be an obstruction. There is a friction between the flow and the filter membrane. There also there is a static generation. And spray electrification, fragmentation of the liquid surfaces produces charged droplets again. Then splash filling, that's where I'm talking about the diplex, where they have an arrangement of a pipe to fill the reactor till bottom of the reactor, so that there is no splash filling. Splash filling in the sense, if I put a pipe only at the top, so it will be directly falling to the bottom, then it will get intact with the bottom, then it will get separated. There it will get generated. Otherwise, if I take the full length pipe till bottom to the tank, so what will happen? There is no splash filling. And also, incidental sparks maybe come from the charged clouds. That is then again lightning generated by the water spray from the cleaning. Even steam leakage also produce charge, and also isolated metal works. A nearby pipeline CO2 discharge from fire extinguisher may also generate a charge. It is not about what type of metal you're using. It is about the kind of physical activity it will generate the static electricity. When you see some of the examples, so working on the floor, even discharging of taking out of a material, even any spray kind of thing, even you're rolling any plastic material with the iron rod, even filling of the material in a tank. Even if you see while doing hesitation in the reactor, then pipeline flow materials, even the powder flow in the chutes. So wherever there is a physical activity, mechanical activity is happening, there the static electricity will generate. Now we'll see some of the operations. These are the only few operations. Maybe you can correlate with your existing operations where it can match with touching and rubbing hand and plastic and handrails, then working on dry floors and flow through a long pipeline or small diameter, increase in diameter, reduce the static charge because it can avoid the friction. And as a friction reduce the of the same flow, then flow through the filters and valves. So here also, due to the friction between the filter membranes and the valve, maybe half opened valve can be an example with respect to valve. Stirring of liquid at the bottom, again, it is about the even a mixie or any agitation happens in the reactor or somewhere where we do mixing of materials. Splash filling of liquids or high velocity flow also can cause static electricity. And two-phase liquid or solid or liquid or gas or air or gas or solid flows and loose floating objects. Even our clothes also, if you're continuously wearing a cloth and taking out of your body also can generate static electricity. Then flow of air, steam or gas through the opening of the hose or any pipeline and directing airflow on near the electronic equipment, compressed air cleaning up the dust, putting or removing synthetic materials or near the electronic equipment, putting on and off the jug synthetic shirt. So as I mentioned, just give an example, any synthetic shirt or material on human body also can generate. The combing of hair, it is a general example. Then process of mixing or agitation, while doing any mixing of materials, raw materials or finished goods based on nature on your operations can also generate. Then rapid flow of powders, pellets or tablets through the chutes or pipeline. These kind of activity also can generate the static electricity. Then when we see machines, so what type of machines can generate? These are the few machines. One is the rollers or roller contact of dissimilar surfaces or moving belt or conveyor on it. Example, rubber mill or paper mills, calendar machines or tire rolls. Running of non-conductive flat belt on pulleys or rollers. Pulverizing machines where the pulverized material passes on surfaces. Pulverized means again powder machines. Then long conveyor belts moving on support rollers where we use the belt conveyors. It will be run over the metallic rollers. Then feed hoppers, silos and pneumatic conveyor where the material slides on the surfaces. So feed hoppers will be hopper may be in different types where we use this provision to feed my equipment or feed my storage or feed my reactor or any other process equipments. And what will be the hazards with this static electricity? So basically, we have seen what type of machines and what type of activities can generate. Now we'll see how it is going to be a danger for us. It is basically frequently generated, but mostly it is not hazardous because it is too weak or leaks of as fast it is generated. It will not last for long. So as early as it generated, as quick as it will get discharged. For its fast leaking and bypassing, a good conductor anti-static device is required to connect the charged surfaces with the earth. So hence it is very weak. In the accumulation or discharge, it gets immediately discharged. So we'll have a good conductor material so that immediately it will get discharged before it is converting into high amounts of electricity. As a rubber is a bad conductor I mean, I can say a good insulator of electricity. It accumulates static electricity to a high degree, and fires in rubber industry are mostly due to discharge of such heavy static charges, where they make this fine rubber powders. Even the fine dust particles in that process can immediately ignite. And if the equipment is not grounded, or the static charge will continue to accumulate, and until it will discharge as a spark. Therefore, grounding by steel plates or copper wires is necessary. Even that friction of the parts or due to the mechanism of the machine, it can generate a static electricity. That's why we used to have the earthing for the each machine, so that whatever the amount of energy it is generated, automatically it gets discharged through the earthing. If you see some of these specific, or even lightning from the sky is nothing but a discharge to the earth on enormous static charge generated and also accumulated between the layers of air and also clouds in the atmosphere. Then if you see some of the specific hazards, shock if a spark is not generated or a charged surface, not grounded, is touched by human body. It is a shocking sensation. With the static discharge, will not get into any fatal or will not get into any burns or something. But it is danger if the discharge happens any flammable atmosphere. Otherwise, with that static discharge, we will not get any shock. Means we'll get the shocking sensation, but it is not such harmful. And fire and explosion, if spark is generated due to the discharge of static charge into any flammable atmosphere, in case of any leakage happens, in case of any spillage happens, or in case of any opening where the open containers or the empty containers are kept it open due to that vapors. In case of such atmosphere creates in such situations also, it leads to accident. Reading or distorted or charged in sensitive instruments, then dust deposition on charged surfaces, clogging or obstruction to free flow of powders in a chutes, silos, and hoppers. These also some of the hazards. Even chutes and hoppers, sometimes pipeline, in case of any blockage happens, they used to try to remove by hammering or nailing it. In those cases also, we should cautious about while cleaning those such kind of blockages. And when we say controls, so how we can control this? One is prevent the charge generation, as we see in a hierarchy of hazard controls. One is like elimination. Then it is not possible prevent the accumulation. Then if this is also not possible, prevent discharge from being hazardous, or prevent the formation of atmosphere near the possibility of static electricity. Either we should do the controls in at the generation stage. We should not allow a situation or an activity, it can accumulate the static electricity. Then if it is not possible, then we'll not allow to accumulate. That's why we use pipelines and also the chutes or any ducts where we have this static jumpers to have a continuity and it gets discharged. Then still it is not possible, and we have to prevent discharge from being hazardous. So it should not discharge create any spark, and also prevent from of a flammable atmosphere near the possibility of static electricity. In last place, we can have controls in generation or creation of any such atmospheres where it can ignite or explode. When we say specific controls, those are the high level controls like a policy kind of controls. So here we can see earthing and the bonding of equipment, pipeline, pipe joints or flanges are parts, and increasing the conductance of the floors, footwear, wheels and tires of the personnel and moving equipment, increasing the conductivity of non-conductors by conductive additives or surface layers, films, etc. And the humidification of atmosphere, even if you humidify the atmosphere, due to the water content in the atmosphere, it is also act as highly conductive. So humidification also one of the key control in the controlling accumulation of static electricity in the atmosphere, and increasing the conductivity of the atmosphere by ionizing and using anti-static and conductive materials, and also static eliminators, earthing for the moving machinery. Then again, using of anti-static belts and anti-static trussing, non-conductive belts and regular intervals. All tanks and vessels and the pipelines containing solvents or flammable liquids, gases should be separately earthed. Bonding of pipelines at the flange joint necessary unless metallic contact. Sometimes we use metallic gaskets. If the pipeline is continuously having metallic gaskets, we need not to have the static jumpers. Otherwise, if any Teflon, any leather or any other type of gaskets apart from metal, then definitely we should have the static jumpers for taking the continuity of this electricity. Then tank wagons like tankers, road tankers should be earthed while loading and unloading with the flammable liquids or gases, and the rail track should be earthed, and also jumpers to be provided to the connect the rail or rail to rail. And while pumping the flammable liquids in the tanks, the inlet pipe should be extended and also discharged at the bottom of the tank. No long feed inlet pipelines and inner lippets of this purpose to desirable. At this time, it is advisable to maintain an inert gas blanketing. Flow velocity should be restricted. Even the velocity, how fast you are unloading, how fast you are loading. Even sometimes we use inert blanketing. Some of the reactions, especially in the chemical process, they use a few reactions at the inert atmosphere. They purge the nitrogen, then they do activity. The pipe and nozzle of the steam or water should be bonded with while a tank cleaning or steaming. Liquid spillages and dust deposits should be removed as early as possible, because of those dust suppression or accumulation of those dust on the charged surfaces also can leads to accidents. And good ventilation, good housekeeping necessary to prevent the flammable concentration. That's where we talk about ventilation or dilution ventilation or local ventilation, where we can take out the dust which is generated, or we can dilute by local dilute ventilation. So these are the pictorial representation, the examples which we have seen. When I say diplex, this is an example where we can have the pipeline till bottom to the tank. I think you would have seen some of this in your workplace if you're already in working a personal, where we have touch pads so that it can discharge. Even these are the I think wristbands, as I take an example in our previous slides, so that you'll be using this wristband and this will be connected to the earthing, so that whatever the static generating during the process of loading the material, it will get discharged. Even these are the very familiar with the name of crocodile clips. So these clips we use for the loading, unloading of materials, even for the road tankers, etc. And sometimes we use these earthing rods also for discharging. Okay, even some insulated mats, so that it can also control the generation and also accumulation. And apart from this, we should also take care of the work clothing, what kind of material or the fabric which we are using, as in basically aprons or overalls we use in the work area, so which are made of, so preferably cotton and nylon materials, or less prone to the generation or accumulation of static electricity. In that angle also we can look into. Okay.
Sir, in your
So-
previous example, actually both will be used for example, if we talk about unloading of a flammable liquid like petrol or diesel, while decantation, one connection will be used for product earthing, and another connection will be used for tank lorry bonding connection. So for the production of vehicle as well as for avoiding accumulation of charges, bonding
in the
connection
storage tank.
for the
Yeah.
product. Yes, both will be used.
Both will be used. Yes. Both will be used.